In a certain digital control system, so a 0 is represented by a -1 volt level, and 1 is going to be represented by a positive 1 volt level. The voltage level is modeled by a discrete random variable, which is known as K for our PDF here. We are going to use this to sketch our PDF. And to sketch our PDF, we'll just use a XY graph like this. We know that we have the K right here, so that means this is going to be f of K. And we have two values on our K axis. We're going to have a -1 and we're going to have a 1. The values here are just going to be, we'll have PB up here. So P like this for our 1, and then we're going to have 1 minus P. So 1 minus P would be something like if we had a 1 value wherever, and we're subtracting P from it. Well, this is P less of 1. So we can just say that it'll be just somewhere right here, right? 1 minus P. So 1 is some value, we're subtracting P from it. You know, P is this big, and then 1 is like right here or something. We should only have like this much left down here. So that is how our PMF is going to look. That'll be A. In part B, what we can look at is when we find the EK and then EK squared and the variance of our K. We'll start with the EK. So with EK, we're going to set this equal to, we know that we have a, if we tie both of these together, and I'll do this one in red, we're going to have, and I'll do this one in blue. We have, if we start with blue, we'll do a -1, and then we know we have our 1 minus P. This is how we find our EK. We've kind of gone over this before in a previous problem down here. So we've calculated the mean before. We're going to continue to do that here. But we have two things. So now for our red, we're just going to add to this. So this is the sum of it. We have 1, and then we have our P. So when we add all of these together, we're going to get a 2P minus 1. So those are the value for our EK. We're also going to do the same thing to our E, but with the K squared. So inside of here, we just have this K squared, and all that's going to do is say that our K is squared. So this part and this part. So this is equal to, if we start out with the blue again, we're just going to have -1 squared. It's just going to be 1. We're going to have 1 minus P. I'll write it out for now. So -1 squared, 1 minus P, plus we're still adding here. We're going to have our 1 squared and then P like this. So this is essentially just going to, once we subtract everything through, leave us with a 1. And now we want to find the variance. I'll do little bullet points so we don't get confused. The variance of K is just going to be equal to, we have our EK squared, and then we're going to subtract this from the I don't know why I keep writing K, EK, and the whole thing squared. So this is going to be equal to 1 minus, we're going to have 2P minus 1 squared. So we essentially have 1 minus 2P minus 1 times 2P minus 1, which would be 4P squared. We have a -4P, and then we would just have -1 times -1, so plus 1. So this will leave us with a total answer, -4P squared plus 4P plus 2. So that should be your answer. I was a little bit uncertain, so we can just double check this. This is just for me. So if you already got it, you're solid. But 1 minus, and then we have 2P minus 1, 2P minus 1, 1 minus, we have our 4P squared, and -4P plus 1. So yeah, we get -4P squared plus 4P, and then this is going to turn into a minus. So actually, we are going to have a minus here. So that should be just like this. And that is the answer for this problem. For part C, it's asking us for what value of P is the variance maximized, and what is this maximized value? Well, for this one, it's going to be setting our variance K equal to 1 to find the maximum value. And when we do this, we're going to want to set our negative 4p squared plus 4p equal to 1. And when we do this, we can factor out something. So let's factor out a 4 first. So we'll have 4p factored out. This is just going to leave us with a negative p plus 1. It's equal to 1. We have 4p is equal to 1. And we have negative p plus 1 is equal to 1. So with something like this, we can just multiply everything by negative 1. And if you do that, we'll get p is equal to 0 here. And then we're also going to get that p is equal to 1/4 here. And because p is equal to 1/4 here, we're going to take this as the maximum value over our 0. So that's how we would look at this problem and how I would go about solving for it.